Welcome to Laser Safety Training, Laser Classification. This training module will explain how lasers are classified according to the hazards they pose and will emphasize the importance of understanding the laser classification system in order that you may protect yourself and others whilst in the lab. To enable users to understand the risks associated with laser systems, an international standard called IEC 60825-1, Safety of Laser Products, was developed. This is accepted throughout most of the world, although the United States have their own set of standards. The laser classification system laid out in this standard document provides detailed information about the different uses of lasers and their various control measures. CE marking of laser products in Europe requires compliance with this standard. In this module, we will outline the 4 main laser classes in the standard, from 1 through to 4, and the increasing hazards associated with each class. Class 1 is subdivided into Class 1 and 1M. Class 2 is subdivided into Class 2 and 2M. Class 3 is divided into 3R and 3B, and Class 4 has no subdivisions. Each laser class defines what labeling schemes, interlocks, key controls and emission indicators are needed. Lasers are classified using this standard based on the hazard they can potentially produce. However, the level of hazard is not solely governed by the laser's power or energy. It is also dependent upon other laser beam properties, which determine the potential size of an illuminated spot on a human retina and the power density of a spot on the skin. Other factors that affect laser classification include the pulse characteristics and the wavelength of the laser light, which both determine the human damage mechanism, how long people are likely to be exposed to laser light, and single fault conditions, such as power supply surge and control measure failure. Single fault conditions are important because the classification of a laser is partially dependent upon the output power. If this increases because of a broken component in the power supply and allows more current to be delivered, this could push the laser into a more dangerous class. Likewise, the failure of an interlock shutter, which is supposed to trigger if the door interlock or enclosure interlock is tripped, can cause a hazardous situation to occur. It is important to understand the differences between upper and lowercase characters and Roman numerals that are used to identify the different types of lasers. These can signify that a laser is labeled according to a different classification system, such as the CDRH or ANSI system used in the United States. Be aware that old lasers may use legacy labeling systems, which do not map easily onto current classification. Speak to your laser safety officer to ensure users are familiar with what different labels mean and how lasers can be disposed of safely. Class 1 is the safest classification of a laser under the IEC 60825-1 standard. Lasers within this class can be either visible or invisible. No signs, training, goggles or laser safety officers are needed as control measures for this class. Class 1M lasers are just as safe as Class 1 for the naked eye. The M in Class 1M stands for magnification and indicates that these lasers can pose a greater eye hazard if you use them with optical instruments, such as binoculars or lenses. Class 1M beams have a higher power or energy than Class 1. The difference is that the beam is either highly divergent or has a sufficiently large diameter to restrict light from entering the human iris to a level below the biological damage threshold. If a lens is used with a divergent beam, or binoculars or camera viewfinder with an expanded beam, the amount of light entering the eye can then become hazardous. So you will need to be aware of these risks and use signage where appropriate. Some laser products, labeled as Class 1, may contain embedded lasers of much higher class, such as Class 3B or 4, which have been made safe by enclosing them in a secure chamber. This significantly reduces the potential hazard they pose and means that the unit can be reclassified as an embedded laser. Embedded lasers are usually considered equivalent to Class 1 lasers, as they pose no greater hazard during normal operation. It is important to keep this in mind when users or service engineers are required to defeat the control measures for servicing or to sustain normal operations. By opening the enclosure, you may be exposing yourself to the much greater hazard of a higher class of laser. Moving from Class 1 to Class 2 lasers, there is an increase in the danger posed by the optical hazard, and only visible lasers can be labeled as Class 2. An example of a consumer product which is a Class 2 laser is a handheld laser pointer. Again, no signs, training, goggles or laser safety officers are required for this class of laser. Class 2 lasers are only considered to be reasonably safe because the standard assumes that users will instinctively react to the laser beam due to their aversion response or blink reflex reaction to a bright light, which limits the potential exposure. Class 2M lasers are considered just as safe as Class 2 for the naked eye, also because of the human aversion response and less viewed through an optical instrument. As with Class 1M, Class 2M refers to the fact that there is an increased hazard when the beam interacts with optical instruments. Again, you will need to be aware of these risks and use signage where appropriate. The R in Class 3R lasers means the reduced or relaxed requirements in terms of how they are used and are lower power than Class 3B lasers. Class 3R and 3B lasers can be either invisible or visible. Please note that you will need minimal training to use Class 3R lasers because they can pose a dangerous optical hazard if exposed to the naked eye. Some laser pointers are 3Rs and as such are only intended for use by trained professionals. A visible Class 3R laser can be up to 5 times the optical power limit of a Class 2 laser. An invisible Class 3R laser is 5 times the power of a Class 1 laser. With Class 3B lasers and above, all safety measures are applicable, including training, signage and interlocks. A laser safety officer must also be notified when using this type of laser, and usage must be very carefully monitored to ensure users are kept safe. Even looking at a partial reflection of a 3B laser can damage your eyes, so sensible control measures are essential. Direct viewing of a Class 3B laser will result in eye damage. Viewing diffuse reflections is normally safe. Any laser that is significantly dangerous to skin, eyes or other materials is classified as Class 4. Class 4 lasers are powerful enough to set combustible materials on fire. Even exposure to a diffuse reflection of a Class 4 laser on a wall, for example, can cause eye injury. As with 3B lasers, whenever Class 4 lasers are in use, there must be the appropriate control measures in place, such as interlocks on doors, warning signs, and a laser safety officer must oversee their use. If you are ever required to perform a laser classification yourself, be aware that this is a far from trivial exercise. You will need specialized measurement equipment and sufficient personal expertise to do this safely. You must remember that once you have classified a laser, you are legally responsible for it being correctly labeled. You can use the tables in the IEC 60825-1 standard document to find the appropriate formula for your laser classification. This module has provided you with an overview of how lasers are classified. We have emphasized the importance of understanding the 4 main laser classes and how they are subdivided. We have also identified other classification systems in use outside of the standard and highlighted the inherent difficulties with successfully classifying a laser yourself. This concludes the module. For more information about laser safety, please contact your laser safety officer.